Welcome back, ladies and gentlemen. Today we're going to talk about dilating a figure on the coordinate plane. So let's get right to it. All right, this problem, draw the image of the triangle ABC. So here's A, B, C, or the triangle we were calling ABC. It's called that because A, B, C, those are the name of the points. We could have called this Ralph, Stan, and Jose. It doesn't matter what we call them, but for ease, just A, B, C. All right, with that, draw the triangle, or draw the image. The image is what we call something after a transformation. So the image is basically a picture or a snapshot of something after it's been moved. All right, then the triangle of ABC after a dilation with a scale factor of 3. So scale factor is how much we're going to enlarge it or how much we are going to reduce it. So remember, enlarge is bigger and reduce is smaller. Now the way we know if it's an enlargement is that our scale factor is greater than 1. Not equal to 1, greater than 1. So anything greater than 1 is going to be a scale factor of 3. And if it's going to be smaller, then it's going to be less than 1. As a matter of fact, if we think back to our rules of math, that should make sense, because anything times 1 is itself. So that means there's no change at all. And anything smaller than 1, so like 3/4 or a decimal. One thing we have to be clear here, smaller is actually from 0. It's got to be less than or equal to 0, and it's also got to be less than 1 to be a reduction. Right now, we're not going to worry about it. There's no such thing as a negative scale factor. It's all either greater than 1 or it's between 0 and 1. That's what this phrase means, between 0 and 1. Boom. All right. Now that we've got all the definitions out of the way of what everything means, let's see how to do this. So really all this means, if we're multiplying by a scale factor of 3, what that means is we're taking any of our coordinates and multiplying each coordinate or each part of the coordinate by 3. What that means is at A, we have a coordinate of 1, 3. At B, we have a coordinate at 2, 3. And at C, we have a coordinate at 2, 1. All right, so if we're going to use a scale factor of 3, that means we're to find our image. By the way, the way we write image is like A prime is image of A. So A prime over here comes from, we're taking A and then 3 times our x value, 1, and 3 times our y value of 3. B prime is going to come from, again, here's the scale factor, so B, 3 times 2, or our x value, and 3 times our y value of 3. And our C prime is going to come from taking C and taking 3 times our x value, which is 2, and 3 times our y value, which is 1. Now we're going to solve all this. Now, I do want to be correct in saying that I need to actually remove these, because this point here is neither A nor B. This is the actual scale factor part of our table. So forgive me for writing A, B, and C there. If you've got it, go ahead and erase it. Make yourself a little note saying this is neither A nor the image of A. This is kind of how we go from A to the image of A. So here we're going to take 3 times 1, and we're going to get 3. So that's where our answer goes. Here we're going to take 3 times 3, which is 9, and we now have our new coordinate. We're going to do the same thing for B, so 3 times 2 is 6, and 3 times 3 is 9. 3 times 2 is 6, and 3 times 1 is 3. So what we're going to be able to do is we can now graph these. We can do 1, 2, 3, and then up to 9. And what we know is at 3, 9, we have the image of A, or also can be said as A prime. Now, we have B primer, the image of B at 6, 9. And then we're going to have C prime at 6, 3. And here we now have our triangle A prime, B prime, C prime. And if I drew a little bit better, use straight edge, things like that, which is what I should have done. I actually had it here. I don't know why I didn't use it. So connect those dots, and I connected those. There's our triangle ABC, or A prime, B prime, C prime. This is a dilation on the coordinate plane of this triangle here. Now there's a couple things we can do to test this. If we go from the center, remember that in a dilation, you have to be able to connect corresponding points, so A to A, and be able to connect them and have them go back to a single point. So B to B would be corresponding points, and C to C would be corresponding points. I hope you notice one thing, that as we're graphing this, C to C, B to B, A to A, they come back to a very specific point. Please make sure that you're paying attention, because all dilations always transfer back, or trace back is a better word, trace back through corresponding points to the origin. By the way, this is how they calculate where bombs are set off. This is where they calculate where any kind of explosion came from. When it goes off, most people don't actually see an explosion, so they don't know exactly where it is, but they can actually trace explosions back to the exact point that they were, because an explosion is like a dilation. It just takes something that's really small and it watch a firecracker, it explodes. Well, if you do that in reverse, you bring it back, that dilation comes back to the point of origin, or where the firecracker was before it exploded. If you wanted to, you can even use this method to determine where A prime, B prime, and C prime are. Now, I'll do that on the next scale, or on the next video, so make sure you're paying attention. Now pause the video and copy what is on your screen into your notebook. Now that you're back, anytime you have to rewatch the video for clarity, to remember something, you need to write what you picked up into your notes. Use arrows, circles, shapes, whatever else you need to make those notes yours. Lastly, ladies and gentlemen, always remember, when you are learning, it's about understanding the process, never about just the answer. We'll see you tomorrow.